Right now, at this very moment, a black hole somewhere in the universe is devouring a planet almost identical to Earth, at nearly the speed of light. This is not science fiction. This is not a hypothesis. This is happening right now. Every second, the cosmos stages events far beyond anything the human mind can picture, and most of the time, we have absolutely no idea. Welcome to Cosmic Explorer. I'm your host, and today I'm taking you deep into the truths about the universe that keep scientists up at night, not because they're boring, but because they're genuinely unsettling. Before we begin, one quick question. Do you believe alien civilizations exist out there? A. Yes. B. No. C. I'm one of them. Whatever you chose, drop your answer in the comments, because by the time this video ends, you may feel completely differently. Buckle up. We're leaving now, destination, the deep universe. This journey is going to make the hair on the back of your neck stand up, and every second will be absolutely worth your time. Let's start with a single question. The observable universe contains roughly 2 trillion galaxies. Each galaxy holds, on average, hundreds of billions of stars. Statistically, a significant fraction of Sun-like stars should have planets in the habitable zone, not too cold, not too hot, just warm enough to keep liquid water on the surface. Scientists estimate that within the Milky Way alone, there could be billions of Earth-like planets. The conditions for life seem almost embarrassingly common. So here's the question that changes everything. If the odds of alien civilizations are this high, where on Earth, or off it, is everyone? Why is the universe so completely, eerily silent? In 1950, physicist Enrico Fermi was eating lunch with colleagues when he casually tossed out that exact question. Nobody had an answer. That moment gave birth to what we now call the Fermi paradox. The universe is vast beyond imagination, civilizations should be everywhere by probability, and yet we hear nothing. Absolutely nothing. The universe is so quiet it feels like a graveyard. Scientists have proposed many explanations over the decades, but one stands out as by far the most chilling of all. It's called the dark forest theory. Once you understand its logic, you will never look at the night sky quite the same way again. The dark forest theory works like this. Every civilization in the universe is like a hunter hiding in a vast, pitch-black forest. They know other hunters are out there in the dark. But nobody dares light a fire. Nobody dares make a sound. Because the moment you reveal your position, you risk being eliminated by something far more powerful. Silence is survival. So alien civilizations may not be absent, they may simply be doing exactly what we would do in the same situation, pretending they don't exist. Which raises a deeply uncomfortable question. If the universe really is a dark forest, then humanity's decades of broadcasting radio signals into space, was that an act of courage, or something closer to a death wish? We even engraved the precise coordinates of Earth onto the Voyager probe and launched it out of the solar system. Have you ever stopped to think, what if someone already received that signal? Drop a new moon in the comments if the dark forest theory makes sense to you, or a glowing star if you think it's just human paranoia. But hold that thought, because what comes next makes the choice even harder. Don't comment just yet, because a real event that actually happened will complicate your answer considerably. In October 2017, an astronomer in Hawaii was scanning the sky when something completely unprecedented appeared on the screen, an object from outside the solar system, moving through it in a way that defied every known explanation. It was traveling far too fast for the sun's gravity to account for its speed. Its shape was described as a long, thin cigar, an aspect ratio of roughly 10:1, unlike anything ever observed in the natural universe. And stranger still, it was accelerating in ways that no known physical model could explain, as if something invisible was actively pushing it forward. Scientists felt the presence of some unseen force driving it through space from within or without. They named it Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. That name carried the full weight of humanity's confusion and fascination, along with dozens of questions that remain unanswered to this day. Harvard astrophysicist Avi Loeb put forward a hypothesis that stunned the scientific community. Oumuamua could be an artificial solar sail from an alien civilization, a spacecraft propelled by the pressure of sunlight and solar wind. The idea ignited fierce debate. The scientific world has not stopped arguing about it since. Most scientists considered the explanation too bold. They proposed natural alternatives, a chunk of nitrogen ice or hydrogen ice being vaporized by solar heat, producing a gas jet that could explain the extra thrust. Plausible, on paper. Except for one problem, nobody observed any gas plume at all. Not a trace of outgassing was ever detected. And then it was simply gone. Arrived without announcement, departed without a trace, leaving nothing behind but a pile of unanswered questions. Picture this, deep space, black as ink, a handful of stars flickering in total silence. Then a thin, elongated shape slices through the void, no trail, no sound, moving too fast for any telescope to properly lock onto. It looped around the sun on a perfect gravitational arc and then disappeared back into the darkness. The entire visit lasted only a few months. If it really was an alien probe, did it spend those months quietly scanning us? Did it record Earth's coordinates, our atmosphere, our biosignatures, and carry them back to somewhere very, very far away? If you were an engineer from an alien civilization, what shape would you design your probe? What capabilities would you give it? Put your blueprint in the comments, I'll reply personally to the most creative ones. But if you thought Oumuamua was mysterious, what comes next will make it seem positively ordinary. In 2007, an astronomer sifting through old data stumbled onto a strange signal. It lasted just a few milliseconds, so brief it was nearly dismissed. But in that tiny sliver of time, it released as much energy as our sun produces across several hundred years, all compressed and detonated in a single instant. This is a fast radio burst, or FRB. At first, scientists assumed it was instrument error or terrestrial interference. But then more appeared, from every direction across the sky. The pattern was the same every time, extremely brief, extraordinarily powerful, and completely unknown in origin. The more they looked, the more they found. The truly strange part, some of these signals repeat with a measurable rhythm. The famous FRB 121102 fires off in a regular, repeating cadence. Rhythm implies pattern. Pattern implies the signal may not be random at all. Because nature, generally speaking, does not schedule its outbursts on a precise, repeating timetable without a reason. The leading scientific explanations involve neutron stars, magnetar bursts, and similar exotic objects. But none of them fully account for the rhythmic repetition. Then someone proposed an idea that's technically outside the mainstream, but once you hear it, you won't be able to shake it easily. It silenced the room when it was first suggested. Fast radio bursts could be the leaked energy output of a cosmic-scale laser propulsion system used by an alien civilization to drive interstellar spacecraft. In principle, if a civilization built a laser array large enough to push a lightweight enough vessel, the energy signature from outside would look exactly like a fast radio burst. Physics doesn't rule it out. Sounds insane? Maybe. But it violates no known law of physics. Close your eyes and imagine this. You're standing at the porthole of a spacecraft, and beyond the glass is absolute cosmic darkness. Then, from some direction, a deep low hum arrives, not through your ears, but as a vibration felt through your entire body. That is energy. An enormous force, released somewhere out there. You don't know where it came from. You don't know if it was intentional. That is exactly what the universe does to astronomers every single day. If you're enjoying this video, hit like right now, let the algorithm carry our signal to more people. Consider it your contribution to interstellar communication. Now let's talk about what might be the universe's biggest lie. Everything your eyes can see, every star, every galaxy, every planet, every person, including you, adds up to just 5% of all the matter and energy in the universe. 5%. The remaining 95% is something we cannot see, cannot touch, and can barely detect at all. Of that 95%, about 27% is called dark matter, and about 68% is called dark energy. How do we know dark matter is real? Because we can see its gravitational fingerprints. By all known physics, stars at the outer edges of a galaxy should orbit more slowly than the inner ones, the same way planets farther from the sun move slower in our own solar system. But observations tell a completely different story. Stars at the outer rim of galaxies move just as fast, or faster, than the ones near the center. Something invisible must be providing enormous extra gravity to hold them in orbit. Without it, those outer stars would have flung themselves off into intergalactic space a very long time ago. So what exactly is dark matter? We genuinely don't know. It emits no light. It reflects no light. It absorbs no light. It passes through your body as if you aren't there at all. Right now, in this exact moment, billions of dark matter particles are cutting straight through your body, and you feel absolutely nothing. No resistance, no signal, no trace. We don't even know if it's a particle in any conventional sense, or something that falls entirely outside every category we've invented. It is everywhere, wrapping around everything, penetrating everything, and it will never let itself be seen or touched. That kind of existence produces a very specific kind of unease, and a very profound sense of awe. If that isn't unsettling enough, here's one more thing. Dark energy is causing the universe to expand at an accelerating rate. At some future point, that expansion will exceed the speed of light. Every other galaxy will cross beyond our observable horizon and vanish from our universe forever, unreachable, undetectable, gone as if they never existed. The Earth of that distant era will drift alone in absolute darkness, surrounded by nothing. The astronomers of that age will have no idea other galaxies ever existed. They'll believe the Milky Way is the entire universe, the same way we today have no idea what might lie beyond the edge of our own observable horizon right now. Which brings me to a question I genuinely can't let go of. Is our current understanding of the cosmos already incomplete in exactly that way? Maybe there are structures beyond our reach that we will never be able to perceive. There is no answer to that question. At least not yet. But it is worth asking every single day. Speaking of questions without answers, let's talk about parallel universes. This is not a science fiction premise. Quantum mechanics contains a legitimate theoretical framework called the many worlds interpretation, formally proposed by physicist Hugh Everett in 1957. It has never stopped generating furious debate in the physics community. The core idea is this: every time a quantum event occurs, the universe splits into multiple parallel branches. Every possible outcome is realized in one branch or another. Right now, you're watching this video. In one parallel universe, another version of you already closed the tab and went to sleep 20 minutes ago. In another branch, you just hit like, and that was an excellent decision. In yet another, that version of you is doing something we absolutely cannot imagine from here. Every choice, every instant, unfolds simultaneously across an uncountable number of branches, generating an infinite web of parallel realities, running in parallel to ours right now. The many worlds interpretation remains a mathematical hypothesis, one that currently cannot be tested by any experiment. But it violates no physical law. In fact, it elegantly resolves some of the strangest behaviors in quantum mechanics, including quantum superposition and the Schrödinger's cat paradox. That makes it harder to dismiss than any science fiction story. If parallel universes are real, then somewhere in the space of all possible realities, one version of humanity has already developed interstellar civilization and is exploring the edge of the cosmos right now. In another, the dinosaurs never went extinct, and the dominant intelligence on Earth is reptilian. Those civilizations exist, just not here, not in this branch. In another universe, quantum entanglement technology is fully mature, and humanity achieved instantaneous communication across light years, perhaps even teleportation. In ours, we're still pointing telescopes at the sky, trying to decode the faint, ambiguous messages the universe occasionally sends our way. Honestly? There's something quietly beautiful about that. Which parallel universe would you most want to wake up in? Tell me in the comments. I read every single reply. Now, for the final chapter, what is the fate of our universe? Scientists have 3 main scenarios. I'll take you through all of them. Every one is more difficult to accept than the last. Scenario 1, heat death. This is currently the most widely accepted conclusion. As the universe keeps expanding, stars burn out one by one, black holes slowly evaporate, and the cosmos reaches a state of maximum entropy, temperature approaching absolute zero, no energy gradients, no chemical reactions possible. The universe doesn't end in an explosion. It simply stops. Eternal darkness. Eternal cold. Eternal silence. Scenario 2, the Big Rip. If dark energy's intensity keeps increasing, it will eventually become powerful enough to tear apart everything, starting with galaxy clusters, then individual galaxies, then solar systems, then planets, then molecules, then atoms. The universe ends not with a whimper, but with absolute, total violence. First, the solar system is ripped apart. Then the planets. Then molecules split. Then atoms are torn open. Finally, even atomic nuclei themselves are shredded. Every particle in the universe ends up drifting alone in a featureless void, not slowly extinguished, but violently dismantled, piece by piece, all the way down to the last subatomic fragment. Scenario 3, the Big Bounce. Perhaps the expansion eventually halts, reverses, and the entire universe contracts back into an infinitely small point, only to detonate in a new Big Bang, birthing a new cosmos. Over and over, without end. Under this scenario, the universe isn't dying. It's breathing. It always has been. It always will be. I'll admit I don't love any of these 3 endings. But if I had to choose, I'd choose the Big Bounce, at least there's another round. What about you? A for Big Rip, B for heat death, C for Big Bounce. Drop your answer and your reasoning in the comments. The most thoughtful response gets pinned. Don't miss it. Let's do a quick recap. Today, we traveled through a corner of the cosmos that keeps scientists genuinely unsettled. The Fermi paradox showed us, a universe this large should be full of voices, but all we hear is silence, and maybe that silence is the most terrifying answer of all. Oumuamua reminded us, unknown visitors may have already passed through. Fast radio bursts tell us, the universe's most powerful signals may be natural, or they may be something else entirely. Dark matter and dark energy revealed, the cosmos we think we know is only 5% of what actually exists. And the many worlds interpretation suggests, in every single moment, another version of you is making a completely different choice. What I find most fascinating about the universe isn't how vast it is, or how mysterious. It's this, it makes every human problem, every anxiety, every conflict feel almost vanishingly small against the scale of everything that exists. And yet, here we are, these tiny, improbable beings, asking the largest questions imaginable, and refusing to stop until we find the answers.